today we are going to dissect an IPv6 address. How we understand an IPv6 address. So first we have to know about this. This is the /64. It indicates the prefix length. So this is an IPv6 address, as you can see. So this is known as the prefix length, the /64. It is 64-bit indicate the prefix length of this IPv6 address. The prefix length indicates the network portion. So which part of the IP address will be the network part? So this is the prefix length will determine this. So as you know, an IPv6 address is 128 bits. And I may have used a /64, which indicates this IPv6 address has got a 64-bit prefix length. All right. Why I've put 64? Because it is recommended to use prefix length /64 bits. So the prefix length, as you can see, indicates the network portion. Which part of your IPv6 address is the network portion? And here it can range from any value from 0 to 128. And why it is recommended to use a prefix length of 64? It is also because for SLAC, stateless address auto configuration needs it to use, because SLAC uses 64-bit for interface ID. So that's why it is recommended to use the prefix length of 64. Prefix length, this is prefix, this is interface ID. So when you have your IPv6 address, so this part here stands for prefix length, so it is a /64, and this is the host portion. So this is how we understand our IPv6 address. I've broken it here. So as I explained to you in my previous video, we have 8 part here, it's around 8. And it has IPv6 address include hexadecimal. 2 types of unicast address. Now, when we are talking about IPv6 address, so it is best known for 2 types of unicast address that we have. We have the global unicast address when we have a link local address. Now, for the global unicast address, this is the part, this address is used so that the device can go outside the network. It is just like a public IPv4 address, so that it moves from its network, it can go anywhere on the internet. So for that, we need a global unicast address. These are globally unique internet routable address, and it can be configured statically or dynamically if you have a DHCP server. Link local address. It's good to note that all devices have a link local address. Whether they have a global unicast address or not, they have to have at least the link local address. And for every IPv6 enabled device, this is a requirement. LLAs are used to communicate with other devices. So on the network, how the device will communicate with other devices, including the gateway. With the gateway, it uses the link local address. So within the LAN, it is the link local address that is important. With IPv6, the term link refers to a subnet. LLAs are confined to a single link, so that is link local address. It will be within the network, within that subnet. It won't be able to talk to another subnet. Good. So next. Now, I told you that it's divided into 2. The interface ID and the prefix length, the network portion. Now that network portion here, let's go back, just show you. We here told you the IPv6 address here. This is the prefix, that is the network portion. This is the internet interface ID, the host portion, the one that we're going to work with to put on different devices. Now, here, this part, all this part here, it is the prefix. That is the network portion. This is the one we put on the devices host portion. The different IP here will be different. So in the prefix, there is this part 001, which is known as a global routing prefix. And this is assigned by the ISP, by the Internet Service Provider. This is the global routing prefix here obtained by the ISP. It is given to the customer or to any site. And for ISPs, it is common to use a /48 as prefix length. All right, for ISPs often use /48 for prefix length. But obviously, every ISP will have its own policy. Now, the global routing prefix now, in the prefix, in the network portion here, it is the global routing prefix that will determine the size of this subnet ID. If this is a /48 and my prefix for the IPv6 address is /64. So if I use 48 here, so here I'll be left with 16 bits. And we have to remember that IPv6 was created with subnetting in mind. So that's IPv6. That's why here definitely it's the subnet ID. Now, if an ISP uses this global routing prefix, let's say it uses a /32. That is 32 bits will be 32 bits here. Then our subnet ID will be 32 bits if our IPv6 address is a /64. If we have a /32 subnet ID, this will indicate how many networks will be able to do if we have a /32 subnet ID. 4.3 billion subnets will be able to make. Will be able to make around 4.3 billion networks. So IPv6 has its raison d'être, and it's not going to, we are not going to lack addresses to put on our devices. Now you see the name interface ID here. What does this indicate? Indicate that the device can contain several interfaces. That is, a laptop can have different network cards. A PC can have a different network card. Servers have different network cards. So each network card is on a different interface. So that's why we call this term has been used here, interface ID. Okay, so here we have a /48 bits global routing prefix. 16 bits is used for the subnet ID. So you see a /48 routing prefix, 16 bits. It gives 64 bits. This is 64 bits. This is 64 bits because the IPv6 address has a /64 as prefix length. Now, the global unicast address has got global routing prefix, subnet ID, and then interface ID. So it's divided into three parts. Global routing prefix, as you know, is assigned by the ISP, by the provider. Subnet ID and then interface is the host portion of your IPv6 address. Link local addresses. Point to be noted. All devices in the network, whether they have a global unicast address or not, we need to have a link local address. All right, so this link local address enables a device to communicate with other IPv6 enabled devices within its network or subnet. Within that same LAN, it can communicate with all the devices, including the router. If we have only link local address, we need IP address only, IPv6 address only for our network. It's not going to go outside the network. So therefore, global routing prefix in that case will not be a requirement. An IPv6 enabled device must have a link local address, LLA. If a device has not been assigned an LLA, then the device will be assigned one automatically. And IPv6 LLAs are in the range of FE80. You will see all your link local address. It starts with FE80, then column /10. It takes 10 bits for its link local address. All right. And this prefix length that we use in IPv6 address. Let's go back here. You've seen this prefix length. It is also making subnetting easier to create and manage subnetting. That's why it's important to have it as /64 or the prefix length. The Internet Committee for Assigned Names and Numbers, ICANN, that is the operator for IANA, allocates IPv6 address to the 5 regional internet registries. That's known as RIR. In the world, we have 5 RIRs: ACNIC, ARIN, RIPE NCC, LAC NIC, AFRINIC. They are the ones who give those will assign the global routing prefix to all the ISPs, to all the telecommunication companies. So, good. So thank you very much for your attention. So those who haven't gone through the first video about IPv6, I'm going to put the link down in the description. So go through the other video of IPv6 as well. Then you'll better understand this part of the explanation in this video. So thank you.